Tom, first of all, what is the output power of the amp, and how is it distributed amongst its channels, and outline some of the highlights of the design philosophy?
Sure, Alan. Let's start with the power supply. One of the things when Ian and I were talking was that how do we get enough power in any channel to be able to drive, an unclipped amplifier into a speaker. So basically I started with I'd say humongous power supply here. It takes everything from the line and will convert it into a plus and a minus 90 volts. So we have a peak of 180 volts on our power supply here. Each one of these black capacitors is 33,000 microfarads at 100 volts, 105 degrees C. So the longevity of these caps is probably longer than me. But this gave us the start for the amplifier because we needed to have a power supply capable of producing as much power into any of the channels as possible. Then came the amplifier problem. How do we make a single channel that can handle all this power, the 1440 watts from the wall socket, and put it into the amplifier and then drive the loudspeaker load? And Alan, I'm going to give you the mic for a second here.
Sure.
We developed this after years of work with not just ourselves but some semiconductor manufacturers, because we have some ICs and some MOSFETs on this that just didn't exist 2 years ago. So we have basically a main board that is a 4-layer board with a lot of copper on it that can take the power supply in it through the digital amplifier section and supply it to the loudspeaker load. We have an input or a daughter board that goes on this that has the analog circuits that are separate for the balanced and the unbalanced. So when you come into the unbalanced, it goes into the unbalanced section. When you come in balanced, it actually stays balanced into the amplifier. So it took us a lot of work to be able to design this 4-layer board and be able to make this thing to where it can, in fact, produce that kind of power into the loudspeaker.
How does the impedance of the loudspeaker load affect the power output of this amplifier?
Well, for example, if you had different impedance speakers like your surrounds or maybe a higher impedance than your main speakers, and that happens quite a bit, the amplifier actually doesn't care what the impedance is. It's just going to supply the amount of power necessary to drive that speaker to the volume level that the processor has told the amplifier to drive it to. So that gives you a nice sound field in your system where you don't have clipping, that if, let's say, your front left and right needed lots of power and the rest of these don't, these won't draw it. All the power will be sent to the front left and right. If it's a center speaker and that happens to be this channel, that'll get the power. So the beauty of the system is that it routes the power anywhere to any speaker that the processor, your Dolby Digital DTS processor, tells it to.
What are the advantages of a digital design like this in the A1400-8 over, say, a traditional Class AB analog amplifier?
Well, in my old days, where I did design these big, high-powered Class AB amplifiers, we would have a chassis twice to 3 times this tall for one channel, because the heat sinking required, the efficiency is so low on a Class AB amp that the heat sinking required and all of the necessary support circuitry to get that heat away from it requires such a large chassis. That's why Ian had those many monoblocks of amplifiers in his system before the A1400.
Okay, thanks so much, Tom and Ian. And that's a short little coverage of Axiom's new A1400-8 multi-channel amplifier with a total power output of 1400 watts, distributed as the amplifier needs it between anywhere from 1 to up to 8 channels. I'm Alan Loft for AxiomAudio.com. Thanks for watching.